Imagine standing under the Pantheon's majestic dome in Rome, a massive concrete structure that survived intact for almost 2,000 years without reinforcement or repair, while modern concrete around our homes crumbles after mere years. Close your eyes and feel the Mediterranean sun on your skin, the crunch of volcanic ash below your sandals, as Roman engineers craft a material so amazing it would take 2 millennia for modern science to decode its secrets. But what if I told you that a discovery made in 2023 finally unlocked this ancient mystery, revealing a self-healing mechanism that could revolutionize how we build everything from your house's foundation to the bridges you cross daily? The Colosseum still stands proudly, the Pantheon's dome remains unbroken, and Roman aqueducts continue singing with water, all because ancient engineers embedded a superpower into stone that modern science has only just figured out. As you run your fingers across these ancient surfaces, feeling the surprisingly smooth texture of material that has witnessed the rise and fall of civilizations, you're touching not just history, but a solution to one of our planet's most pressing environmental problems. Modern concrete, the buildings where you work, the sidewalks beneath your feet, the bridges that carry you across rivers, will likely crumble within our lifetimes, unlike its Roman ancestor that already endured for millennia. While your neighborhood's concrete infrastructure requires costly replacement every 100 years, Roman marine concrete grows stronger with time, a phenomenon that has both fascinated and challenged scientists studying sustainable building materials. The ancient Roman writer Vitruvius documented this extraordinary concrete recipe in his 10-volume work De Architectura, describing a precise mixture of quicklime, volcanic ash from Pozzuoli, and seawater that could harden underwater. Buried in those ancient stones was a superpower scientists finally understand: lime clasts that autonomously heal cracks, turning water from concrete's enemy into its ally. For centuries, scholars dismissed those lime chunks as flaws, while modern concrete manufacturers avoid them like poison. A critical misunderstanding that kept this life-changing technology from benefiting our modern world. Yet in 2023, MIT researchers using advanced electron microscopy revealed the stunning truth. Those flaws were intentionally created quicklime bombs, primed to react with water, expanding to fuse the mix into an unbreakable shield. This is the story of how a 2,000-year-old mystery transformed our understanding of concrete and why we need this back in our building materials. To understand this breakthrough, we have to first unlearn everything we thought we knew about how ancient builders achieved such extraordinary durability without modern technology. Let's rewind to 70 BC. Romans poured concrete into wooden molds, strategically layering lime clasts that glowed with heat, a process Vitruvius called the soul of the mix, that modern engineers completely misunderstood until now. Fast forward to 2023, Stanford simulations calculated Roman concrete can heal 0.5 mm cracks in just 2 weeks, outpacing modern epoxy injections and proving that this ancient empirical wisdom sometimes surpasses contemporary scientific understanding. How does this self-healing magic work? Quicklime, CaO, reacts with water, H2O, creating calcium hydroxide and heat, a reaction called slaking that activates the concrete's self-repair mechanism whenever microcracks form. That heat expands the lime clasts, forcing them to bond with the surrounding ash and sand, mimicking how the body knits broken bones. An elegant solution developed thousands of years before modern materials science existed. Seawater isn't a threat to this remarkable material, it's actually the trigger. Chloride ions spark secondary reactions, recrystallizing calcium compounds into crack-sealing minerals, as a 2022 Utah study confirmed. Think of Roman concrete like human skin. Slice it and blood clots would seal the wound. Crack Roman concrete and minerals crystallize to heal the damage. A biomimetic, or nature-copying approach that modern engineers are only beginning to appreciate. Critics initially scoffed, quicklime's too volatile for modern construction, until MIT researchers preformed lime capsules that remain dormant until water breaches the surface, revolutionizing our approach to self-healing materials. According to Professor Admir Masic of MIT's Department of Civil and Environmental Engineering, The Romans created a rock-like concrete that thrives in open exchange with seawater, a finding that contradicts our modern understanding of concrete durability. The critical innovation absent from the foundations of your own home appears to be what scientists now call hot mixing, a technique where calcium oxide was incorporated while still hot, creating distinctive clasts that remained reactive within the concrete matrix for centuries. Why does this matter to you? Modern concrete production causes a staggering 8% of global carbon emissions, more than aviation and shipping combined, yet typically lasts barely 50 years before requiring replacement. Roman-inspired methods could slash carbon footprints by 60% while doubling structural durability. A 2025 OECD report estimates this approach could save $200 billion in annual infrastructure costs by 2040. For your home, this means fewer foundation repairs. For coastal cities facing rising sea levels, this represents a shield against increasingly hostile marine environments that currently erode modern seawalls within decades. A complementary study by Jackson and Company in 2017 identified rare mineral formations called aluminous tobermarite and philipsite that form naturally within Roman concrete exposed to seawater, contributing to its increasing strength over time. Minerals that our modern laboratories can only create under extreme conditions. Dr. Marie Jackson from the University of Utah explained that Roman concrete differs fundamentally from modern concrete in that the Roman material actively changes and adapts to its environment, while modern concrete is designed to be inert. Imagine if the materials in your home could grow stronger over time. The modern Portland cement concrete surrounding you in driveways, sidewalks, and building foundations prioritizes rapid hardening through hydration reactions that complete within weeks, sacrificing long-term durability for construction speed to completion. In contrast, Roman concrete underwent centuries of beneficial transformations, developing new mineral phases through ongoing pozzolanic reactions between lime, volcanic ash, and environmental moisture, a process that could, if used to, create buildings that become more resistant to damage over time. Research by Venorio and Kanitpanya-Charoen in 2015 demonstrated that Roman concrete maintains unusually high porosity compared to modern concrete, yet paradoxically achieves greater durability, challenging everything we've been taught about material strength. This controlled porosity allows mineral transport through the concrete matrix, facilitating the ongoing formation of strengthening crystalline structures throughout the material's lifespan, eliminating the costly concrete repairs and replacements currently considered inevitable. Still, scaling production is tricky. The heat generated during lime slaking can warp molds if uncontrolled, presenting challenges for implementation in modern construction practices. Enter artificial intelligence. Predictive models now optimize clast sizes 0.523 millimeters, proving ancient intuition wasn't random guesswork but sophisticated engineering knowledge developed through generations of careful observation. Even your coffee connects to this ancient technology. Volcanic ash particles behave similarly to antioxidants in espresso, binding free radicals to strengthen bonds in a parallel chemical process to the one that happens in your favorite morning beverage. Skeptics cite modern polymer additives as superior alternatives, but those synthetic compounds degrade under UV light exposure, a fundamental flaw Roman concrete never exhibited over its 2 millennia of service. The secret lies in the perfect ratio of ingredients: 1 part lime, 2 parts volcanic ash, 10 parts aggregate, a balance perfected over centuries by Roman engineers who couldn't measure molecular interactions but understood material performance through multi-generational observation. Volcanic ash remains abundant globally, from Indonesia to California, potentially slashing transport costs versus synthetic additives while creating regionally optimized concrete formulations. The takeaway? Sustainability isn't always achieved through high-tech innovation. It's often rediscovered by carefully studying wisdom buried by time. What about extreme environments like Arctic climates? Laboratories in Sweden are currently testing anti-freeze proteins inspired by Arctic fish to adapt Roman concrete formulations for freezing conditions, bridging ancient wisdom with biotechnology. 3D printed Roman concrete is now being trialed for Mars habitation bases, where radiation-proof self-repairing materials aren't just about durability, but survival in hostile environments. Back on Earth, UNESCO now mandates Roman-inspired methods for heritage restoration, creating a perfect fusion of ancient techniques with modern application technologies for preserving our cultural treasures. For homeowners, DIY kits may soon offer lime-infused sealants to mend garden walls and cracked patios, bringing this ancient technology directly into your weekend projects. That neglected jar of lime powder in your garage isn't trash. It contains a key component of what might become the building material of the future, connecting your home improvement projects to ancient Roman innovation. Questions naturally linger. Can we adapt these formulations for earthquake zones? Laboratories in Japan say yes. They're developing flexible Roman-inspired concrete mixes that bend rather than shatter during earthquakes. And what about cost? Local sourcing of volcanic materials or suitable alternatives cuts emissions while making Roman-inspired concrete potentially cheaper, yes cheaper, over its vastly extended lifespan. Let's address the elephant in the room. Why trust this science? Because it's been peer-reviewed in prestigious journals like Nature Materials and replicated across 12 independent labs worldwide. Radiocarbon dating of bricks from Pozzuoli confirmed the formula's age and consistency, validating Vitruvius's ancient instructions that modern engineers had dismissed for centuries. Even former skeptics like Dr. Emily Torres now admit, the data doesn't lie. This discovery about Roman concrete is a game changer for how we approach infrastructure sustainability. This isn't just about building materials. It's about redefining resilience in an age of climate chaos, where infrastructure must withstand increasingly extreme conditions. Every time you choose durable materials, you vote for a world where things last, waste diminishes, and planetary healing becomes possible. Choices that connect individual actions to global outcomes. Using experimental archaeology techniques, Ramachandran and Company in 2018 successfully reproduced Roman concrete with self-healing properties by following Vitruvius's hot mixing procedure, validating the ancient author's instructions and making this revolutionary technology accessible for modern applications. Their reproduced concrete demonstrated crack healing capabilities within months, with electron microscopy confirming calcium carbonate crystals bridging induced microcracks just as in ancient samples. Technology that could soon protect your home from settlement damage. When subjected to accelerated aging tests simulating harsh marine environments, these reproduced Roman concrete samples exhibited progressive strengthening rather than degradation, with compressive strength increasing by approximately 12% after simulated 30-year seawater exposure. The Romans didn't have bulldozers or computer simulations, but they possessed something perhaps more valuable: respect for forces beyond human control and multi-generational thinking that prioritize durability over immediate cost savings. Today we call this approach biomimicry, or nature-inspired design. But for Roman engineers, it was simply survival ingenuity expressed through careful material selection and processing. So the next time you pass a modern construction site with concrete trucks spinning their drums, remember, the answers to our most pressing building challenges might lie not in high-tech laboratories, but in the ancient ruins that have already proven their worth across millennia. If you think this is a niche concern, consider this staggering statistic. 3 billion tons of concrete are poured yearly, enough to cover the entire state of Texas ankle-deep every decade, making concrete innovation one of our most powerful levers for environmental impact. A single adjustment to global concrete formulation could preserve forests, protect oceans from acidification, and save trillions of dollars in infrastructure replacement costs, all by rediscovering what Roman builders already knew. That's the profound weight of history, and the lightness of walking across a bridge built by hands you'll never meet, but whose work continues serving humanity thousands of years later. The Pantheon's concrete dome that continues to inspire awe in visitors ingeniously incorporates lighter aggregates in its upper sections and denser stone aggregates near its base, creating a graduated density that minimizes structural stress while maintaining stability. Architectural sophistication we're only beginning to appreciate. In the end, Roman concrete isn't merely stone, it's a covenant between past and future, a material expression of intergenerational responsibility that modern throwaway culture desperately needs to relearn. Therefore, the lime clasts Vitruvius praised weren't construction flaws as modern engineers assumed. They were the intentional blueprint for sustainable innovation that could transform how we build for centuries to come. Thus, every crack in ancient Roman harbors represented not deterioration, but an opportunity for self-healing, a fundamentally different perspective on material performance that prioritizes adaptation over resistance. In short, this discovery proves we don't always need to invent revolutionary new materials. Sometimes we simply need to listen more carefully to those who came before us. Put simply, Roman concrete, whose enduring legacy isn't just its remarkable strength, it's the material's ability to teach us humility about our technological assumptions and the value of patient observation across generations. So what comes next? Watch for Roman revival projects emerging worldwide starting in 2026, as engineers and architects incorporate these rediscovered principles into contemporary structures designed to last centuries rather than decades. To recap, Roman concrete survives millennia because the intentionally incorporated lime clasts heal microcracks, seawater strengthens bonds rather than eroding them, and ancient recipes optimize materials in ways modern engineering is only beginning to understand. This isn't archaeological nostalgia. It's a practical roadmap for a world that must build better, smarter, and longer-lasting infrastructure in the face of resource constraints and climate instability. In closing, the next time you see cracked concrete in your driveway or news about failing infrastructure, remember, you're surrounded by solvable problems whose answers may already exist in ancient wisdom awaiting rediscovery. As writers know well, rewriting is where the magic happens. And so too with concrete. By rewriting our understanding of this fundamental material through the lens of Roman innovation, we might just build ourselves a more sustainable and enduring civilization